circular motion. So circular motion means this is a circle. This is a circle. Okay. Suppose a person here is moving in this direction on this circle. On this circular path, this person is moving. This is the initial position of this person. Okay. This is the initial position. Now this person is moving along the circular path. Suppose this is the A point at point A initially. Now finally this person reached to this point. Point suppose B. This is the final position. Now here the concept of straight line motion like displacement, velocity will be used also, and I have told you properly what is the displacement and what is the velocity. So basically this person started the motion from this point and finally this person is at point B. Okay. Now suppose R is the radius of the circle. Just a minute, I am just drawing the radius. This is the initially, this is the condition. So this is R, is the radius of the circle, capital R. Okay. So this, and what is this? This is the center of the circle. So I have just meet the center of the circle. Okay. With this the final position and initial position. This also will be the radius of the circle. This also will be the radius of the circle. So from here to here, there will be some angle swept by the person in going from A point to B point. There will be some angle swept. Suppose that angle swept will be theta. What is this? Theta. And this center of the circle is O. Center of the circle is O. Okay. Keep in mind first this thing. What happens? There was a person. This person is moving from point A and moving and moving and moving, and finally person reached at point B. Okay, and this person is moving along a circular path. This is the center of the circle. I have joined this center with the initial position, joined this center with the final position. So this is the angle theta. This is the angle theta. Now basically what we are discussing in a circular motion, we are discussing the kinematics. Kinematics of circular motion. What is the meaning of kinematics? Here we will not study the cause of the motion, only we will study like angular velocity, like the displacement. These things we will discuss. Okay, things which describe the motion we will study here. Okay, not the cause of the motion. Okay, so kinematics of circular motion we are studying. So basically this angle theta is known as the angular displacement. And angular displacement is represented by theta. This is the angular displacement. I have told you the linear displacement now. I have told you the displacement in the last chapter. Displacement. Hmm. So this theta, and what will be the displacement? Displacement will be this. If I am talking about the displacement, so this will be the displacement. The straight line distance. The straight line distance will be the initial position and the final position. Okay. So here will be the linear displacement, and you can say displacement. Linear, and linear displacement I have represented with small s. And what is the linear displacement here? AB. AB will be the your linear displacement. And what is this theta? Theta is the angular displacement. So basically, this thing we have already discussed. Now we will focus on this angular displacement. Okay. This angular displacement is angle, and we measure angle in degree or radian. We measure angle in degree or radian. Okay. So we can say here measurement of theta. What is theta? Angular displacement. So this can be measured in two ways. First way is to measure the angle in degree, like 30 degree, 40 degree, 50 degree. Another way to measure the angle is radian. Okay. So basically, what is degree and radian? You can say these are the unit of angular displacement, or these are the unit of angle. Angular displacement is basically the angle. Okay. So this radian is the SI unit. Shafruddin, tell me what will be the SI unit of displacement? Hmm? SI unit of displacement. Linear displacement.
Unit of displacement or linear displacement?
Both are the same thing. I am okay, no
Meter,
problem.
meter.
So
Is it meter?
Okay, yes. And remember, actually after the straight line motion there na, I have to start the vectors. So as you have told me that A1 level is starting your teacher, so that is why vector we have not studied. So you should have the basic idea of the vectors. Okay. So basically this theta is a vector, but this theta is axial vector. The theta is the axial vector. The effect of this theta can be seen along the axis. Okay. So if you want to find the direction of the theta, so theta we know clockwise and anti-clockwise, but that is not the direction of the theta. Direction of the theta is given by right hand thumb rule. What is the right hand thumb rule? So now we can remove this. Now this person is moving from A to B. This person, see this figure of circle. This person is moving from A point to B point. So this person is moving in anti-clockwise direction. So if you want to find the direction of the theta, then curl your finger along a sense of motion. So, and the direction of thumb will give you the direction of theta. So just curl your fingers of right hand along the direction of motion like this. So your thumb will be towards you. Okay. So this means the direction of theta will be outwards, towards you or towards the observer. Okay. Like linear displacement have the direction north, south, east, west. Angular displacement have the direction towards the observer, away from the observer, depending upon the situation in which uh, plane the body is performing the motion. Okay, Shafruddin.
Yes,
So
sir.
here you will here you will write direction of theta will be towards the reader. Reader means I am the reader, you are the reader. Got it? This thing.
Yes, sir.
So this is the angular displacement. First thing. Okay, now we will describe the relation between the angular displacement and the linear displacement. Relation between the angular displacement and linear displacement. So relation between angular displacement and linear displacement, that is S. So basically relation is very simple. A formula should be known. This angle theta is equal to arc length, this arc length AB. I am not talking about the straight AB. I am talking about this circular type AB. Okay, this arc AB divided by the radius. Do you know this relation between the angle and the arc length?
Yeah.
Okay. Okay, so you can just define the relation. So theta is equal to arc length AB divided by radius R. So what is your theta? Theta is theta. Arc length. You can say arc length is arc length. Arc length is arc length. Arc length is this length AB. Okay, this length AB. So this will be your S is your angular displacement. But this is valid when your theta is very small. Okay, if your theta is small, then you can say this straight line distance AB and this curved AB will be same. Okay, in that case you can say. both the distances will become same. So you can write Sy r. Okay. So this is the relation between the angular displacement and the linear displacement. Got it?
Yes, sir.
You can write for small theta. Now this is the angular displacement. Now we will discuss another term, angular velocity. Angular velocity. This is represented by omega. And I have told you the velocity. Velocity is displacement divided by time. Told you na velocity. So like this, there is one thing, angular velocity. So see what is angular velocity. So basically, angular velocity, I will relate it with the linear velocity. What is linear velocity? Divided by the linear displacement divided by the time. Like this, linear velocity I have represented with v. Okay, a linear displacement is s and this is t. So basically your linear velocity will be displacement divided by time. Your angular velocity will be angular displacement by time. Your angular velocity will be angular displacement by time. Is it or not? Earlier motion was the linear motion. Linear motion means motion in a straight line. Now we are discussing the angular motion or circular motion we are discussing. Okay. So two ways to calculate the angular velocity, like in straight line, velocity are of two types. One is the average and another is instantaneous velocity. Okay. So your omega, what is your omega? This is your angular velocity. Your angular velocity can be measured average angular velocity and instantaneous angular velocity. Now what is average angular velocity? First you should know what is the average displacement. Not average displacement. You should know what is average velocity, total distance, total displacement divided by total time. Okay. Average velocity. I am talking about the average velocity. Okay. So average velocity is given by delta s by delta t. I have told you delta s by delta t was average velocity. Now average angular velocity is given by delta theta divided by delta t. Are you getting?
Yes.
You have to think, you have to relate both the linear motion and angular motion, otherwise there will be the confusion always. Your average angular velocity will be delta theta by delta t, and your linear will be delta s by delta t. What is delta s? Linear displacement, total linear displacement. What is delta theta? Total angular displacement.
Okay.
Now instantaneous velocity, what is instantaneous velocity? ds by dt there.
Yes.
Now angular instantaneous velocity means omega instantaneous is given by d theta by dt.
By dt. So d is the delta, right? Or
Actually, d things I have told you in there also in the last chapter. Delta we use for calculating the average thing. Okay, for a definite period of time. For a definite period of time, we use average, and for instant of time we use this d.
okay.
I have told you na, their angular means instantaneous velocity and average velocity. Why we have used delta and why we have used d?
Yes.
Okay, so now we will talk about the unit of omega. Unit of omega will be, what is omega? Omega is theta divided by t. Unit of theta is radian. SI unit of theta is radian. SI unit of time. So unit of omega will be radian per second. Okay. SI unit of omega will be radian per second. Okay, now take the screenshot. Just a minute. Today's lecture will be very slow. Okay, because this circular motion is different from that linear motion, so it will take time to, okay, understand the things.
So,
Completed?
yes, sir.
Okay.
Yes, sir. One, sir.
Just wait a minute, wait a minute. This is linear. Linear means for a straight line motion. Now take the screenshot. And one more thing I want to write here. This omega is also the axial vector. Omega is also axial vector. Direction of omega is given by right hand from rule. Direction of omega means This person is moving in this direction. Okay. Suppose with angular velocity omega. Omega is the angular velocity. Okay, remember this point. So what you will do, you will curl your finger along the sense of omega, and along the sense of the motion, the thumb will give you the direction. So direction of omega here, the direction of omega will be towards the reader. Okay. So here you can write direction of omega will be towards reader. Now note down these 2 points also.
Yes.
Okay. So basically what we have, uh, what I have told you, average angular velocity will be given by delta theta by delta t. Okay, delta theta by delta t, and instantaneous omega is given by d theta by dt. Okay, and what is the relation between the angular displacement and the linear displacement? Angular displacement is equal to linear displacement divided by time, divided by the radius of the circle.
Yes, sir.
This theta is the angular displacement, s is the linear displacement, r is the radius.
Yeah.
Okay, so now we will solve one question. Here angular displacement theta is changing with time, 2t square plus 2. This is given. They are asking find angular velocity in 2 seconds and at 2 seconds. See the difference in 2 seconds, at 2 seconds. So here in 2 seconds means from 0 to 2 seconds, means we have to calculate the average or we have to calculate the instantaneous here. For example, let me give you one example. Suppose you are moving in your car. You are moving in your car from this A distance to some distance B. You are moving a straight line. You are moving in a straight line in a car from A to B. And suppose this is a point P, this is a point Q. At A, your speed is 10 meter per second. Here is 20 meter per second. Here is 30 meter per second. Here is 50 meter per second. Is it or not? So if I want, if I ask you what is the speed or what is the velocity for in motion from A to B, what will you say? What will be your answer? Because here your speed is 10, here 20, here 30, here 50. What you will say?
I have to find the difference or displacement. You want me to find the velocity of this?
I am just saying. See what I am saying first. you are moving from this A to B. Okay.
Yeah.
During the motion at A, your velocity is 10 meter per second. At point P, your velocity is 20 meter per second. At point Q, your velocity is 30 meter per second. At point B, your velocity is 50 meter per second. If I am asking find find speed, or you can say velocity from A to B.
I minus
Then what do
50
you?
minus 10.
Hmm?
I need to minus 50 minus 10, then I get 40. Is the answer.
Minus 50? How you will get minus 50?
No, I meant minus the 50 and the 10. You get 40.
Actually, you will try to calculate the average from A to B, na? The person is asking the speed from A to B. It means you will not tell that your speed will be 10. You will not tell that your speed will be 20. You will say you will calculate the average of all. Then you will tell the average speed. Okay. If I am asking what is your speed or velocity at P, then what will be your answer? At P.
20.
20. Very good. Means if someone is asking the velocity at a particular instant, then that speed will be instantaneous speed. And
Yeah.
if a person is asking the speed for a time interval, for a definite time interval, means you will tell the average speed. You will tell the average speed. So here this concept will be applied. So first they are asking angular velocity in 2 seconds. In 2 seconds means what you will calculate here? Average angular velocity or instantaneous angular velocity?
Instantaneous angular velocity.
And at 2 seconds what you will calculate? Hmm? Okay. At means they are at 2 seconds. Na? If they are saying at 2 seconds means he or she wants the speed at that particular moment. Means you have to calculate the instantaneous. In 2
Okay.
seconds means 0 to 2 seconds.
Okay.
In 2 seconds means from the starting to 2 seconds means they want average. Is it or not? This thing should be clear.
Okay. Okay.
Now it's clear?
Yeah.
Okay. Now see, angular displacement. What is theta? I have told you. What is theta? Angular displacement. Theta was the angular displacement. No? This is the angular displacement. T is the time. Okay. This T is time. So your angular displacement is changing with time. Okay, you will put different value of time, you will get different. So angular velocity in 2 seconds. Okay, angular velocity in 2 seconds you want to calculate, means you will calculate average angular velocity. Average angular velocity from 0 to 2 seconds. What is the formula of average angular velocity? Delta theta divided by delta t.
Oh yeah, delta theta by delta t.
Yeah. Delta theta divided by delta t. What is delta theta? Theta 2 means theta final minus theta initial, theta 2 minus theta 1. And what is delta t? Delta t is the time interval.
Yeah.
You can write here t2 minus t1 if you want. Okay, now what is theta 2? Theta 2. Theta 2 means they are asking the average angular velocity from 0 to 2 seconds. In 2 seconds means 0 to 2 seconds. Remember this point. So this is your T2 and this is your T1. So what you will do, you will put T is equal to 2 in this equation. So this is 2 into 2 square plus 2. This will become 10.
Yes. I know. It'll become 8.
Oh,
No, it's 10. It's 10.
this will become 10, na? 10 and this is theta. So SI unit of theta is radian. 10 radian. Theta 1. Theta 1 means you will put T is equal to 0. So put T is equal to 0 in theta. You will get 2 radian per second. 2 radian. Now you can find theta 2 minus theta 1. Now you can find theta 2. What is your theta 2? 10. What is your theta 1? 2. What is your T2? 2. What is your T1? 1. This will become 8 by 1 means your average angular velocity will be 8 radian per second. Radian per second is the unit or SI unit of angular velocity. Actually, this is different. Okay, in linear motion we have the velocity. Simple velocity is displacement divided by time. But here in circular motion we have to calculate the angular velocity by angular displacement divided by time. Got it? Okay,
Yes.
now in the next part they are asking at 2 seconds. At 2 seconds means the angular velocity at t is equal to 2 seconds means instantaneous angular velocity they are asking indirectly. Instantaneous angular velocity, what is the formula of instantaneous angular velocity?
D theta by dt.
Very good. D theta by dt means we have to do the differentiation here. D theta by dt. So, and this you have to tell at t is equal to 2 seconds. So here you will write d by dt and you will put the value of theta. What is theta? 2t square plus 2. So we can differentiate this. I have told you how to differentiate. If theta is given this, na, if theta is given 2t square plus 2, then if you want to find d theta by dt, then how you will differentiate? You will multiply this power with this 2. So this will become 4 and here is your t square. Then you will decrease one power.
I see.
And I have told you differentiation of constant thing is 0. So your value will be 40. Okay, so again I am telling the differentiation because differentiation will be required in question. Suppose y is equal to 5x square plus 3x cube is given and I want the differentiation of y with respect to x, that is dy by dx. So what I will do, I will multiply the power with 5, so this will become 10.
10x1 plus
Oh, very
9x.
good, very good, very good. 9x square, very good. If I want to differentiate this 5x, what will be the dy by dx? Only 5.
Yeah, 5.
If y is equal to 5 written constant, then what will be the dy by dx?
0.
0. Very good. This thing you should know. Okay. Now I think we can calculate What will be the answer of differentiation of this 2t square plus 2?
4t plus 0.
4t plus 0. And instead of t, what you will put? T is equal to 2, because they are asking the instantaneous velocity at 2 seconds. Okay, so here you will write 4 into 2. 4 into 2 na? Instead of t, you will put 2. So you will get 8 radian per second. 8 radian per second. Okay. Take the screenshot. Done. Okay, just done. I am teaching slow today because this is the circular motion. So I know that it takes time to just process, okay, by the mind. And take the screenshot of differentiation also, because differentiation will be required.
Yes. Answer.
No, I know, I know. So now we will discuss what we have right till now. What do we have? We have one angular velocity. That angular velocity is represented by omega. This thing.
Yeah.
Linear velocity and velocity are same thing. I am saying the linear velocity because I want to differentiate. Okay.
Yeah. You put v.
So
Right?
yeah, v. Linear velocity is v. Okay. So this is your angular velocity. This is your linear velocity. So what is the angular velocity? What first we have studied the linear velocity. First we will discuss the linear velocity. So linear velocity is the
S by t.
displacement
By time.
by time. Angular velocity is angular displacement divided by time. Divide by time. So you can write this angular displacement is represented by theta and time is represented by t. Displacement is represented by small s, time t. Clear? This thing clear? Okay.
Yes.
Now both are vector quantities. Both are vector quantities. This is also a vector. Angular velocity is also a vector. Linear velocity is also a vector. So this is a polar vector.
The other one is axial vector, right?
No. That one, the axial vector. And this is the axial vector, so its direction is given by right hand. I have told you how to use right hand thumb rule.
Yeah.
Right hand thumb rule. This thing is clear. Okay, so what is the unit of the velocity or linear velocity? Meter per second. Meter per second. Why meter per second? Because the velocity is given by the displacement divided by time. Unit of displacement is meter, unit of time is second. So unit of this, just here you can write. Okay, so this is the polar vector. So talking about now unit. Here we can write. Unit is meter per second. M is for meter, okay? M is for meter. And unit of this will be radian per second. Radian per second. Why? Because unit of theta is radian, unit of time is second. Okay. So now, what is the average linear velocity? Delta S divided by delta T. What is the average angular velocity?
DS.
Delta theta divided by delta T. Delta theta by delta T. Okay. I am writing the differences. What is the instantaneous linear velocity? Tell me what is the instantaneous linear velocity? ds divided by dt. What is the instantaneous angular velocity? d theta divided by dt. Not del. Del we will use for average. So this difference should be clear. Otherwise, always you will confuse. Always, always. So this difference.
Zoom out. I just want
Yeah. Just a minute. I am just making one line also. Okay, so that you can get it properly. Okay. I think this should be here. No, it's fine. And just a minute. I don't want any kind of confusion because I have told you the things in a proper way. Okay, so I think I will zoom out. Now take the screenshot.
That's it.
So this thing we should know. Okay, Shafruddin, any confusion? Actually, now we are relating the angular motion with the linear motion. Why? There is a reason. Because if we will study the angular motion by relating with the linear motion, things will become easy for us. Okay, things will become easy for us. Otherwise, this thing will be very complicated. Okay. Okay, now there is one more thing for the circular motion. Relation between linear velocity and angular velocity. Angular velocity omega. So in one line for the circular motion, I want to write the relation is v is equal to r omega. This will be the relation, but we will see how this is the relation. This is a circle, suppose. So same thing we will use. This is the radius r. Initially the body is at A. Finally the body is somewhere here. This is also the radius r, because this is the circle, is B. In going from A to B, suppose angle swept will be delta theta. Okay, and this displacement AB, suppose delta S. What is delta theta? Angular displacement. Delta theta is angular displacement. Delta S is the linear displacement. Okay, delta theta is angular displacement. Delta S is linear displacement. Okay, and this body is moving. The body is moving in a circular path with an angular velocity of omega. With an angular velocity of omega, the body is moving. Okay, so we know that the linear velocity of the particle or the body, this body is moving with the angular velocity omega. I am writing here omega. Okay, so we know that the linear velocity of the particle will be delta S divided by delta t. Okay, suppose delta t will be the time taken in going from A to B. Delta t. Time interval. And what is omega? Omega will be delta theta divided by delta t. Generally we talk about the angular velocity. Okay, so this is the average velocity, this is average angular velocity. Okay, now we will use one relation here. Theta is equal to S divided by t. So we can write this delta theta is equal to delta S by delta t. We can write this. So here we can calculate from here delta S. Okay, so your delta S will become delta theta into delta t. Is it or not? So now you can put this value here. Delta S. Delta S is delta theta into delta S is delta theta into delta t, and this will be the delta t. Just a minute. Oh, okay. Actually, this delta theta we will put here. Okay, this delta theta na we will put here. So this is your omega. This is delta theta is delta S by delta t. Oh yeah, I have written the wrong relation. Just a minute. So basically this thing is clear. V is equal to delta S by delta t, omega is equal to delta theta by delta t. We know that theta is equal to S by R, not T. Okay, so I can write delta theta is equal to delta S by R. Okay, delta S by R. So here we can from here we can calculate delta s. So this will become delta theta into r, and we can put delta s here. When we will put delta s here, so we will get delta theta into r divided by delta t. And what is this delta theta by delta t? Omega. So this is the relation between the linear and the angular velocity. And note, this relation is valid only for circular motion. Only for circular motion. Okay. S is equal to r theta, or theta is equal to s by r, and one more relation, v is equal to r omega, or omega is equal to v by r. So both these relations are valid only for the circular motion. Okay. So now we have the relation. Now if I want to, this is a circle, no? If I want to find the direction of the linear velocity at A point and at B point, okay, this body is moving with the angular velocity omega in this direction. So if I want to find the direction of the linear velocity at point A and at point B, then this direction will be simply given by drawing a tangent at that point. Okay, drawing a tangent to the circle at that point. So this will be the direction of your velocity, linear velocity. Get it? So direction of the linear velocity will be given by drawing a tangent at that point. Suppose I want to calculate the direction of the linear velocity here. So what I will do, I will draw a tangent here. Okay, so there is one more point. In circular motion, the linear velocity is always perpendicular to the radius of circle. See why this is. We know that this is a circle and this is the radius of the circle, and this is the radius now. If here at this point you want the direction of the velocity, direction of the linear velocity, so what will be the direction of the linear velocity? Direction of the linear velocity will be this. So you can, and what is this r? R will be the perpendicular to this tangent. Okay, so this tangent and this radius, that is perpendicular, always perpendicular. Okay, angle between the radius and the direction of the linear velocity will be 90 degree always. Okay, suppose suppose here you can take here one point here and then find the direction of the velocity. So here the direction of the velocity will be tangent to this point. Okay, so here is also the velocity and radius